this is the address vlab.amrita.edu. Okay, so this web page will open it up, and then you need to go to the physical sciences. In the physical sciences, you go down. Okay, and again there is this solid state physics virtual lab, which you can see on the second last number, and there you find out this resistivity by 4 probe method. Okay, so this experiment we are going to perform today. You Okay, so this web page will open it up, and you see on the top, this is the address of this particular experiment. Okay, and again, if you look at it out, these are the tapes. Now you people may be familiar with that. Okay, so theory, procedure, self-evaluation, simulator, assignment, reference, and feedback. So all such things are there. Let me go through with all one by one. So first you look at, let me annotate also. So you look at the aim, and many a times I told you that aims are very important. Okay, so here you need to fulfill this one. Only one aim is there, that is to determine the resistivity of semiconductors by 4 probe method. Now interestingly, why we are saying 4 probe method, because in this setup we have 4 metal pins, and pin is nothing but probe only, so that's why this setup name is 4 probe setup or 4 probe method name. Coming to the operators. Okay, so here you see the operators required. All such components whichever we are going to use in this setup is listed over here. You can go through that carefully. Okay, and slightly different content is also given for your understanding. Okay, methodology, etc. So you just go through that carefully. Now coming to the bottom side again. So this figure is very important. Okay, because this is the base part of experiment. So let me highlight that. This figure I am talking about. Okay, now in this figure, if you see carefully, so there are 4 pins. This is pin number 1, this pin number 2, this is pin number 3, and this is your pin number 4. Okay, and this black color strip which you see, this one, this is your semiconductor sample. Okay, in layer form. So semiconductor is there. On the top of that you have connected these 4 pins. Remember, these pins are of metal. Okay, so these metal pins we have connected on this semiconductor sample. Okay, uniformly you see, and the distance between each pin you see again, from 1 to 2, 2 to 3, or 3 to 4, the distance is uniform. Okay, constant you see, and I have denoted with s, small s, that is the distance between each probe. And importantly, if you see the connectivity part, so this connectivity, again you check it out, the inner probe, that means this probe 2 and 3. So these 2 probe I have connected with voltmeter. Okay, here you see this voltmeter, and the outer probe, probe number 1 and probe number 4, I have connected with this ammeter. Okay, and this is of course power supply you required. Okay, but you people are familiar with that this ammeter always we are connecting in series in a circuit, and this voltmeter part we are always connecting in parallel. Okay, so that's how I have connected in this arrangement, and this is the correct arrangement. Let me remind you one more time why you are getting the resistivity of semiconductor. Now there is a case also. Suppose that case you need to think of what will happen if I change this arrangement, that rather than connecting the inner probe with voltmeter, if I connect the inner probe with ammeter and the outer probe with voltmeter, then what will happen? So you need to think out logically. In this diagram itself, in this figure itself, it is very clear why we have connected in this order, why not in the other way. Okay, so just go through it carefully, you will come to know about your answer. And here is again few other things they have given. This is the conducting sheet or whatever the semiconductor material, basically the part layer. Okay, and this is the width, this one which we are noting with the W, and these are all are pins. Basically you see the distance also. So same setup in slightly different arrangement they have put it in the figure number 2 for more clarity in the picture. Now let's come to the downside again. So as usual, theory and procedure part I am leaving for you people. Okay, you can go through the theory for better understanding, but little bit things we can discuss. As you see this formula, this is the famous formula which relates the resistance and resistivity of a particular material. You are familiar with that. Okay, so just go through that carefully. For such stuff you will come to know the differences, etc. Okay, other points are given listed over here. This is your part to read it out. Then you go down. Okay, so here is they have given, okay, all such important steps you have to keep in mind. They have given over here how it is connected, everything, so that you have a proper working setup. And then if you go down, so these are the two formulas we are going to use. Let me annotate one more time. One is this one, formula number 2, and this one, formula number 3. Now if you remember, there are two rows you can see. One is row, this one, and another is row naught, this one. Okay, so what is the difference between these two? So rho is your semiconductor's resistivity, which is the ultimate aim you need to do in this experiment, and this rho naught is again the resistivity only, but it is of the entire setup. Why I'm saying entire setup? Because this resistivity is corresponding to a semiconductor, as well as some part of the metal is also there, because metal pins are connected to the semiconductor sample to measure the resistivity. Okay, so that is why the outcome which you get from this experiment, it provides you this rho naught, the sum of, I mean, the combination of resistivity of semiconductor and metal. So that will be rho naught. But then our aim was to find out the resistivity of semiconductor. So that's why there is a factor which we are knowing as a divisor, you see, denoted with F. Okay, depending on W and S. This W and S already we discussed. W is the width basically, and S is the distance between the pins. So this divisor for a particular WS, it is a fixed number. Okay, and many a times manufacturers are giving this number. Okay, so don't need to worry with that. So what you have to do is you need to divide the resistivity of the entire setup, that is rho naught, divide by F. Okay, then only you will get the resistivity of your semiconductor. Fine. But so this is the formula, is very clear. But how to find this rho naught? Because F is given by the manufacturer, they have given you for a particular sample material, etc. But what about this rho naught? How to calculate this? So for rho naught, this is the formula we need to use, that is V upon I into 2 pi S. V is the voltage, okay, I is the current, and S is the distance between the probes. Okay, all such things they have given over here again for your purpose, clarity purpose. Okay, now let's come down again. Again they have given, there is one more thing you need to find out in this experiment, that is the temperature dependence of the resistivity of semiconductor. Though this process is this name, but what you have to do in this is you have to find out the energy band gap of or energy band gap of semiconductor material. So you look at this formula. This formula is relating this resistivity to this energy band gap. Okay, so you modified it again, simplify it, and you can find out the value of energy band gap. And many a times what we are preferring is we are plotting a graph. Okay, we are plotting a graph between here it is maybe log and rho. Okay, natural log of rho and 1 upon t. Okay, so this graph will be like this curvature, something like you will get a curve like this if you plot it, and this straight line up to this much part, let me change the color. So only this much straight line you have to consider for calculating the slope. So you find out the slope from this graph and then put it in this formula. Okay, so then you can calculate the value of energy band gap. So remember, energy band gap you have to calculate not from this formula, because this will give you the theoretical, but you need to find out from the experiment. So you have to go for this graph arrangement, log rho, natural log of rho versus 1 upon t. If you plot it, you get a curve like this, and then you have to take the slope of this line. Okay, and then you place it, you will get your answer. Fine. So just keep in mind other things you are knowing very well. K is the Boltzmann constant, so you are knowing the value of that. T is the temperature. Okay, so whatever the temperature we are going to vary in the setup, that temperature you have to note it down. Okay, that's how you can find out the energy band gap. And these are some applications you see, okay, where this particular experiment can be useful, this technique can be useful, so you can go through that. Now important, there is one more important thing I want to discuss with you people, that let me go. Yeah, so this entire setup this much, okay, we are keeping inside the oven, because our purpose is we need to vary the temperature and note down the corresponding resistivity of the material. So this entire setup, these pins, we are keeping inside the oven, and that oven we are going to heat. Okay, so let's, all such things we'll discuss in the simulator part again. Now coming to the procedure part. So in the procedure you see all such details about the box, etc. they have given over here. you can also see, let me annotate. Okay, this boxes, etc., range of current, select material. So carefully go through that. Okay, otherwise I will also discuss it during the case of simulator, but it's a good idea if you go through carefully all such things. And then if you come down, okay, here they have given the procedure also, how to perform it. Okay, you just go through it carefully. All such steps, maybe 10 to 11 is 10 11 steps are there, and they have given the procedure for real lab also, so you can also go through that for better clarity in the experiment. And now coming to this table, okay, observations and calculations part. So here you see in the table 1, I mean in this table, in the column number 1, here you need to write the temperature in Kelvin. Okay, even though in the simulator the temperature in degree Celsius, but now you need to write down into the Kelvin. So you have to convert it basically and write down the answer over here. Similarly, you need to write down the note down the voltage. Okay, jitna bhi aata hai, and then you need to use this current. Okay, current also use. So what we are doing is, generally in this experiment the current value we are keeping at fixed number. Okay, so in real life we are keeping it 5 milliampere, but in virtual one it is up to you. Either you can keep it 2 milliampere, 3, 4, 5 milliampere, whatever the number you keep it, but make sure once you decided the current value you have to keep it constant. Okay, don't need to change during the experiment. So that's what you have to keep in mind. And resistivity part, you calculate with the formula and write down the answers over here. That's how you can do that. Now if you come down again, okay, so these formulas you need to use. This F value also you see they have given, as I said, this is mostly provided by the manufacturer itself. So here also they have given the value of F. You provide it over here, write down the answer of rho over here. Rho naught also you can calculate it out, and at the last you write the value of rho in this result part. Okay, because actually we are interested in the resistivity of semiconductor only, not for the entire setup. So you write down the value of rho in this part. So this is how theory and procedures are. Now, again, I suggested you people to go through it carefully from both the parts, because then only you will be able to perform the third component, that is self-evaluation. So if you've gone through properly, you must be able to select the correct answer from for these MCQs. Okay, so just check out your knowledge of understanding of this experiment, the answers, and click on submit to see the answer. And then you come to this simulator part. So this simulator will open it up. Now again I am repeating, I'm suggesting you people that this setup, okay, this particular experiment, it will be working very nicely if you perform in the Google Chrome, because few of the buttons are disabled in the Firefox as well as in the Chrome also. But anyway, if you are using in Firefox, then also we have the alternate. But for clarity, if you want, then you can try with Google Chrome. So that choice is up to you. Now come to this experiment part. Okay, and but before that, first you need to identify the component. So let me identify for you people. This is your power supply. Okay, not power supply, basically current source you say. Okay, from that you need to supply the current or keep the current. Okay, and so it's the current source in milliampere. And then you see this is the voltmeter, digital voltmeter they have written over here. And this is the controller part. Okay, controller part of this oven. So you see this oven, the structure is very familiar to you. This is the oven. Inside we are keeping our 4 pins, 4 probes setup. Okay, so how this setup looks like, so let me come to that again. Okay, here you see first on this side you have to select the material. So that is germanium or silicon, you have to select it, because both are the pure semiconductor. So whichever way you like you select. Okay, I am keeping, let's say, germanium. Then you see range of current, again there is a drop down, you select the range, and suppose if you select it, there will be difference will be over here. Here you see some changes anyway, but 20 milliampere range is enough, because we are setting our current around 5 milliampere or so. So 20 milliampere range is perfect. Okay, there is a slider. Okay, you move it, you see, and the number will display, the number will change in this one. Okay, current source you see. So whatever be the number, you move it out, you select it, and that number will be displayed over here. But remember, again I am saying, current you have to keep it at fixed number. So whichever number you like, you can keep that number. Okay, so let's say in real life we are keeping at 5 milliampere. So this time also I will keep at 5 milliampere like this. Now coming to this oven. Okay, so suppose if you want to see what is exactly inside this oven, so you click on this checkbox. Okay, so now you see the components inside the oven, you can check it out. So all that setup which I told to you, okay, that is inside this oven. Okay, pin number one, I mean probe 1, probe 2, probe 3, probe 4 are there, entire setup. And interestingly, if you see, there are two pins connected with the voltmeter, two pins I have connected with the emitter side. So that is why two wires we are taking out from this setup, and same we have connected with this either current source or from the voltmeter source as per the diagram which we have seen in the theory or procedure component. Okay, so that's how. And similar setup we are having in the real lab also, almost similar. All such components will be there. Even this controller also there to control the temperature of the oven. Fine. Now coming to the next part, this one, range of oven. So this is the multiplier, 1 times or 10 times. Okay, so accordingly this particular range will change. So right now you see 25. Why? Because it is a one time multiplier. But if I change this 10 times, so you see it will be 2.5. Okay, so but final reading when you take, then you have to multiply it with this multiplier. So 2.5 into 10, same number you will get it. So basically it is just a way of representing the thing, just like either you represent 1 centimeter, sorry, 1 meter, or you represent 100 centimeter. Okay, meanings are almost same, so same way. So it's better to keep to this one, don't make complex unnecessary. So let's say one time is okay, and then you have to click on this button set. Okay, you click on that set button, and you see right now the temperature, then you see temperature is at by default at 25, but you can go up to 95 degree also. Fine. So there is an interval of 5. So I suggest you people to take the reading at every interval, like 25, then 30, 35, 40, 45, like that you go on. And how to take the readings, because you see in the procedure itself they have given that once you press the set button, other three will enable. But you see in the Firefox it is not enabled right now, it is still in the disable mode, so don't need to worry. This in the Chrome it will be working fine, but if you are using Mozilla or any other, then you can control from this side. Let me annotate from where you can control. So this is the part. Okay, here you see wait is written, run is written. So like that you can control from this, you just press the buttons over here. So then also this experiment is working fine. Okay, so now what you have to do is, you have click on the set button already. Now this temperature range you have to vary. Let's say आपको 25 से बढ़ा के 30 पे करना है, so you keep it 30. Okay, but अभी number will be displayed over here because you set it, but it is not actually moved 25 to 30 in a step. So what you do, you click on this button over here, run. So you see 25, then 26, 27. Okay, you see this part 28, 29 and 30 पे जाके वो stop हो जाएगा. Clear? So that's how, after going to this, okay, now you have to note down the reading of voltage. Okay, so first you need to decide the range of voltmeter. So you see there are multiple categories: 1 millivolt, 10 millivolt, 100 millivolt, 1 volt, 10 volt. So right now by default it is at 1 millivolt, but you see there is zero in the display in the voltmeter. Let me annotate. In this voltmeter it is displaying 0. Why? Because the voltage range is more than this millivolt. Okay, your voltage value is more than this millivolt value, that is why you see 0 over here. But in real lab you people will see 1. So 1 is the indicator that your readings are beyond your scale. Okay, but in virtual one they have represented with 0, but otherwise if you look at to the real lab experiments, whatever with the digital components or circuits are there, digital devices are there, micrometer or voltmeter, if it is displaying 1, simple 1, that means the actual reading of particular quantity is more than this range whichever is on the scale. So what you have to do is, you have to increase the range. So rather than 1 millivolt to voltmeter range, you need to increase. So let me make it kitna kare dekho one by one. So if I keep 10 millivolt, then also you see it is 0 only. If you go 100 millivolt, then also you see it is 0 only. But if you go 1 volt, now you see the number. Okay, so that means 1 volt is the perfect range where you can see the readings of this voltmeter. Okay, even though you can go for 10 volt also, then also you will see the same number. Okay, so basically voltmeter you need to set in terms of, I mean in the range of volt only. So either 1 volt or 10 volt. So I suggest you can keep 1 or 10, whichever way you like. Okay, so keep that. and then you go down slightly. Okay, and all such readings, as I said, और लास्ट में आपको इस बटन पे क्लिक करना है, you click on that show result. It so is it clear? Okay, so after doing that, again you have to repeat the same thing. Again you have to repeat the same thing, like let's make it 30°. Okay, again click on the set button, make it 30°, 35, 40, 45, like that you go on. Okay, and then you have to note down the corresponding voltage value. So I suggest you can go up to the 95 if you are interested, but otherwise at least 8 to 10 readings you can take it out. Okay, and note down the corresponding values. Again there is a table over here also. Let me annotate this. Yeah, so here you can write temperature after converting from degree Celsius to this Kelvin. You write it down. Voltage you note it down. Current already we have kept at fixed number. You write it down and calculate and write the final answer over here. So that's how you can perform it, or directly you can note down in your notebook. So that is how you will get the this experiment. You will complete this experiment, and after completing, if you want to try out with some other material, then you can select the other one. Okay, but otherwise, I will suggest once you decided, then don't change anything. Okay, एक बार complete करने के बाद ही आपको दूसरे पे जाना है. So like that, you go on, complete the experiment, and come to this assignment tab. Some numericals they have given, so you just try to solve it out if it is possible for you. Okay, then come to the reference. So all such books or wavelengths they have given, whichever they have used in this experiment. So it is always a good idea to refer the content which I am suggesting over here. And then of course you can go to the feedback part for providing the feedback. If you like it or if you want to suggest something, then you can provide the feedback over here. So that's how you can complete this practical in very simple manner.